Thank you very much for coming today. It's great to be back here in Noosa, and thanks to Phil and his team for putting on another great conference. Everyone in this room will know about rare earths because for the last 6 months, or probably since Donald Trump became the President of the US, it's been one of the most hotly discussed topics and probably the most strategic mineral class on the planet. So I'll try and give you a little bit of insight about that today, what it means for Meteoric, why this is the next rare earth project anywhere on the planet, and why it's the best. Blah, blah. Right, the company, we've been around since 2004, and since 2017 I've been the managing director. I stepped aside when we made a rare earth discovery. We've traditionally been a gold company, but in the history of the company, they've looked at gold, copper, diamonds, iron ore, cobalt, back to gold, and now rare earth. So it's had a very long history. When we made this acquisition, we were 1 cent and we had a market cap of $10 million. And in the weeks preceding that, I knew that the deal was getting close, and I was actually here at this conference. It was a very exciting time for me, and I haven't been back since, so it's reminded me a lot of that exciting time because, you know, we've been as high as 30 cents and we have a market cap now of about 500 million. There's a lot of stock out there, but that's pretty typical. Only the US investors are freaked out by that. I just want to look at the recent gyrations in the share price and explain why our share price is affected by certain outside events. So our share price, in early 2024, China started to screw down the world rare earth price and took a kilo of NdPr down to about $60 a pound, and all the rare earth companies went backwards because no one could produce at that price. It's just not feasible. Now our scoping study and our feasibility study says that we can, and that's why we, with hand on heart, say that we're the best project. And then in April this year, China put because of the Trump tariff war, China put a complete ban on the export of rare earths to the US. Okay, and I'll explain why in a minute, but rare earths are very critical to the US Defence Department. And so Trump has not got the leading hand in the tariff wars because of that very thing. So China banned rare earth export, or made it so difficult that it wasn't funny, and all the rare earth companies jumped, right? You can see that jump happens in a day. So we'd been really struggling in the low price regime and the fact that we were doing feasibility studies, and we start to jump. In July of this year, the US government put $500 million there's only 3 rare earth mines in the Western world. MP Materials, Mount Weld in Australia, and we actually have the discoverer of the Mount Weld deposit in the audience today, and a project called Serra Verde in Brazil. And only 2 of those are public. So the US government put $500 million into MP Materials, and again, our price shot up. Then we had some environmental struggles where we needed a particular environmental prover called the Congiapa. That got denied. Now, there was a huge kerfuffle about that, and I can talk about that at the booth, but it was an illegal vote. There's a bit of Brazil shenanigans. That got reversed a couple of months later, and you can see since then we've had quite a spectacular run. China has recently relaxed the ban because Trump has relaxed the tariffs, and we've pulled back a bit. But again, even in the last few days, China have said, yes, we relaxed the ban, but we're not exporting any rare earths to the DOD, which is where the US, DOD being Department of Defence. So I think there's a lot more to play out here. But I want to take you a step back and tell you, what are rare earths? Okay, because this is crucial, and you have to understand this because they are different than any other mineral class. And people will say, well, rare earths are not that rare. And that's sort of true because the rare earths are actually 17 different elements. They're not one, they're not gold or nickel, but they're 17. So straight away, you've got to divide that abundance by 17. And as you go across this grouping in the periodic table, the abundance of each one gets less and less and less as you go to the right. So by the time you get down to the heavies, they're very rare, okay? So the light rare earths break up in yellow and the heavies are in blue. Now, why do we love rare earths and why are they important? Okay? They're important because the magnetic ones, which are highlighted in red there, are very, very magnetic. So if you look at an iron magnet, it's called ferrite. And forget about the scale, but let's just say that's a 3.5. Okay, and they're the magnets that you played with when you were a kid, right? And you know, trying to push the hard ends, the opposite, the plus to the minus, you can't get them together, and then the opposite attract. Rare earth magnets, praseodymium, neodymium magnets, are about 15 times stronger. So for the same magnetic force, you use much, much less weight. And in every electric motor requires rare magnets, right? Your windscreen wipers, your car windows, every electric car motor, every missile fin, there's enormous, every nuclear submarine, everyone needs rare earths. And it's because of their amazingly powerful magnetism, and because when we dose them, and this is really important, the samarium and the terbium and dysprosium ones operate at a much higher temperature. You might not know this, but if you took your horseshoe magnet when you were a kid and you put it in the fire, in the coals, when you pulled it out, it's no longer a magnet. It's gone, and it never comes back. The rare earth magnets survive to a much, much higher temperature, so at high performance engines, that's why they work. Right? Now I want to just talk a little bit about our project, but also a bit about rare earth geology. Our project is a clay deposit, and I'll come back to what that means, but it formed inside of a volcano only 70 million years ago. It's a giant circle, and pretty much everything inside that circle is rare earth mineralised. So that's a really important point. But there's a big town to the north, and really you can't go into the northern portion. Okay? Whoop, sorry, I've gone one too many. So forget that northern portion. Our ground is in grey to the south, and every one of those yellow dots is a drill hole, and every one of the red dots is a diamond drill hole. So we've done a lot. Now, I've just got to skip a slide here because I've got them slightly in the wrong order, I think. Now I can't go forward. That's the volcano in cross-section. And all of that pink stuff in the middle is the volcanic rock, or the intrusive rock, if you're a geo. But what we're looking at is only mining the clay on top. And this is the big thing. This is the big difference, and you have to understand this. The Chinese developed this clay mining 30 or 40 years ago. I knew I said million years ago, because I'm a geo. And 30, 40 million years ago is not long. What I actually meant was 30 or 40 years ago. And they found out that when you weather the rock and turn it into clay, you destroy the rare earth minerals and you release those minerals. So this is a rare earth mineral, this coffee cup, right? I want you to imagine that. And it's got rare earths inside it. And so to get those rare earths out, what I have to do is destroy the coffee cup, and I have to extract them. And then this happens with every rare earth deposit. I get different rare earths. You saw that there are 17, and some rare earth deposits have a lot of the orange ones, and some have a lot of the blue ones, and everyone's a bit different. And because every rare earth has its own value, different rare earth deposits have different values. Okay? But the process of destroying this mineral, which is, monazite, xenotime, is really difficult. And to destroy this mineral, first of all, you have to make a concentrate, so you have to float it. That's not too hard. But it has an SG, a specific gravity of other minerals that are quite similar, so that's not easy. So you destroy this mineral and you make a con, and then you have to attack it with 1 pH, right, and high temperature. So that's really hard. Now, in the clay environment, what happens is nature has destroyed this mineral already. So this cup has been destroyed by nature. And I'm going to make a giant mess here in a second. But all those rare earths now sit not in a 3-dimensional mineral, but on the surface of a 2-dimensional mineral, which is a clay. And they are very weakly bonded. And we can wash them off the clay. And this is the secret to the clay deposits. You wash the rare earths off the clay, so there's no crushing, there's no grinding, there's no acid. In fact, the liquid that we use to dissolve the rare earths has about the same, has a pH of 5. Now, what else has a pH of 5? Right? Beer has a pH of 5. So that's how noxious our chemicals are, right? And if you watch this liquid, it'll change colour very quickly. The rare earth reaction in solution happens really quickly. Now, in reality, We use ammonium sulfate to precipitate that, to bring them into solution. But that's all we do. And this is okay, right? Environmentally, I could drink our liquid. I probably won't, but... And that's quite disgusting. But what I'm saying is this is the most environmentally mining process you'll ever see. Right? So, let me get on with it, because I'm already running out of time. We mine it, we wash it in beer, effectively, with a bit of ammonium sulfate in it. We pull out the rare earths, we reprecipitate them, we wash the clays, we put it back. That's it. No hole in the ground, no nothing. We are a long way down the track. We will be the next rare earth mine in the world. We are just about to finish our pilot plant in the next week. These are photos of the pilot plant. We will be producing mixed rare earth concentrate from December. And that will go out to the people we're trying to do deals with. We have a full feasibility study. It's all online. We are in the middle of our DFS, done by Ausenco, and today's moderator is introduced us. He's from Ausenco. We've done a scoping study. We've done a pre-feas. We're nearly finished the DFS. Amazingly low cost. Lowest cost in the world, right? We can produce at the low spot price that China forced the market to. $440 million to build the whole plant. Go and have a look at everyone else's capital costs. Go and look at the Australian costs for Australian projects. $1 billion, $2 billion. And then they've got to still destroy the cup and get it out at 1 pH, so their OPEX is high as well. Don't worry too much about this, but the yellow graph talks about our costs over the first 20 years. And these are various price productions, but they're months old. The new consensus price is $130. The difference, what you have to look at here is the difference between where the yellow bar is and where the red bar is, right? None of our predictions at the time, when we look at NPV and stuff, the prices have gone nuts, and that's because the US has set a base price of $110 a kilo for NdPr now. That's the deal that they did with MP Materials. So the price is bifurcated. There's now a China price and a US price. Everything that we're doing is trying to feed our material into the US. Sorry, we've got offtake partners already. We haven't signed binding agreements, but NEO in Estonia are doing separation. Ucore, it's a trial separation of metallium. We've got agreements, and I haven't talked about this yet, but in the next few weeks, we'll get our environmental licence. We will become the first environmentally approved project anywhere in the world to build the next rare earth mine. So we're right at the head of the queue. And that's what we're going to build. It's going to process about 6 million tonnes a year, and it's going to produce, and again, these are just numbers, don't worry about them. But that's our first project. And then we're going to build another one in the north, and we're going to double our production. And it's real, right? That's not real yet. That's a computer-generated image, but it's designed. It's ready to go, right? We've just got to finish the DFS and build it. Now, you might be saying, well, 3 years ago, you're a $10 million company, and now you're a $500 million company. I shouldn't buy. This is why you're here, right? There are only 2 public companies who mine and produce rare earths in the Western world, MP Materials and Lynas. They have market caps around $18 to $20 million. This slide's a little bit old, and those numbers might have varied. It's a month old. But they have market caps in the order of 20 to... So the yellow is their market cap, and the blue is how much rare earth they produce. We'll produce about 2/3 of what Lynas does, and our market cap is 500 million. We're 2 years from production. Where is this stock going to go? So don't mess around, get in. It has the holy trinity of projects. It is the largest... Right? Sorry to the Catholics. I'm a Catholic, I can say that. It is the largest project in contained rare earth. We've gone from 0 to 1.5 billion tonnes in 3 years because we know how to drill, because we're Aussies, right? And if there's drillers in the audience, congratulations to you. It's the largest, it's the highest grade ionic clay in the world by a factor of about 2 or 3. And I'm wrapping up. And it has the best recovery because grade and recovery are related. This is the best project. If it's not in your portfolio, buy it now. Come and talk to me at the booth. Thank you very much.